Before we begin today's episode, I want to plug that I have a Patreon linked in the description, and that on there you'll be able to vote on future videos, get early access to my paleo art, early access to videos at some point when I actually have people on there, and get early access to my scripts before the videos get recorded. As of right now, I am between jobs, so I would really appreciate any help that people can give at this point in time. And from now on, I'm also going to be uploading my audio recordings for each episode to Patreon before they go live. And let's get on with the review of episode 2 of season 2 of Prehistoric Planet, Badlands. Our episode begins in the Deccan Traps, which were a large igneous province that was active in the latest Cretaceous of India. The Deccan Traps erupted roughly between 66.3 and 65.6 million years ago, meaning that they formed both just before and just after the dinosaurs went extinct. They were way larger than any igneous site active today, and if you want to see their overall size of these flood basalts, then here's a map of them from this 2001 paper by Celine Desert and colleagues. Yeah, everything shaded is this huge igneous province. It's thought that the lava flows might have covered over 1.5 million square kilometers, and they are around 2 kilometers thick in some places. In their 2014 review of the influence of volcanic activity on the vertebrate fauna of the Deccan Volcanic Province, paleontologists Guntapalli Prasad and Ashok Sahni found that the abundance and diversity of dinosaur fauna seems to have significantly declined in the region after the first phase of volcanism. They noted that this might be because the flood basalts were devastating the local fauna, but it also might be the result of preservation bias. It has often been argued that the Deccan Traps may have had a significant role in the end Cretaceous mass extinction, though a fair amount of recent work seems to indicate that they had little influence on the global mass extinction at all. That said, this is very much still a matter of contention that I suspect we'll see many papers continue to debate well into the future. That said, Indian vertebrate paleontologist Dhananjay Mohabi has noted on Twitter that the dinosaur fauna disappear in India a little bit before the Cretaceous-Paleogene boundary, and he suggests that this, plus their evident decline during the Deccan volcanism, which I mentioned earlier, might indicate that the dinosaurs living in India could have actually been wiped out by the volcanism just before the asteroid hit and wiped dinosaurs out elsewhere. We enter the Deccan just before this extinction may have taken place, and here we encounter a herd of female sauropods belonging to the genus Isosaurus. Isosaurus is known from postcranial remains which display the unusual proportions shown here, with notably long front limbs. While the name Isosaurus might imply that the genus was named for the ancient Egyptian deity Isis, I was surprised to learn that they were actually named after the Indian Statistics Institute, or ISI. The unusual proportions of this sauropod, with its very long forelimbs, are true to what we know of its anatomy, with quite a lot of its skeleton being known, albeit from scattered and damaged material. When we put those bones together, all of which are from one individual, the picture we get is of a bizarre animal with a high sloping posture and proportionately short forearm despite the rest of its arm being very long. So what we see here is a really accurate portrayal of the animal's proportions, and they even give the necks the right kind of curved shape that we'd expect on their tops from the unusual neural spines present. The Isosaurus are shown using the volcanoes as a source of geothermal heat to incubate their eggs. There are several sauropod egg clutch sites from a number of different sites between the Deccan lava flows, many of which come from species which appear to be still unknown to science. Unlike what is presented here, they seem to have been deposited a little bit away from the volcanic centers, near to water bodies in calcareous sand and sandy limestone forming environments. That said, Diman et al. Did note that the high concentration of sauropod nests in the Lamenta Formation did invite the possibility of colonial nesting, such as we see here, noting that there is strong evidence for group nesting behavior in sauropods from elsewhere in the world, though it's difficult to be sure of whether or not this was occurring in the Deccan region due to it not entirely being clear whether or not all of the sites were dug at the same time as one another. That said, it does seem very likely. Diman and colleagues did describe the nests as being buried, and noted that there was a reasonable possibility that geothermal heat was used to keep the nests warm, such as is shown here. Whether or not this is the case, we do know that the eggs of Deccan sauropods were fully buried below the surface of the ground, as shown in the later segment, where we see the sauropod babies climbing out through the sediment, as was described by Diman and colleagues. While this may or may not be the case for Deccan sauropods, we do know that sauropods from elsewhere certainly did make use of geothermal heat to incubate their eggs, thanks to the presence of 80 successive buried sauropod egg clutches right next to a series of mineral veins indicative of the presence of geysers, which have been described from the Los Llanos Formation in Sangesta Geological Park, Argentina. So, we know that sauropods elsewhere did make use of geothermal settings to keep their eggs warm, and we have direct evidence for this kind of behavior in modern animals in the form of certain birds. So, all in all, this is a really nice sequence that I genuinely can't fault. Our next segment follows an assortment of animals, beginning with a family of velociraptors, set once again in the deserts of Mongolia. In the first episode of this review series, I covered the velociraptor's reconstruction shown here, as well as the potentially coeval formation of the Jadocta, Baranguyo, and Nemegt formations, and the potential for Velociraptor to have coexisted with the other animals observed within the series, as well as how wonderfully accurate the reconstruction of the animal is. Since you can all learn about that in part 1, I shan't go into that here. The scene moves on to follow a mixed herd of sauropods, including the unnamed Mongolian titanosaur which featured in the first episode. Again, to learn about this, watch that episode. And a smaller sauropod named only as a Nemegtosaur. The fact that they are referred to as Nemegtosaurs and not Nemegtosaurus specifically means that they may in fact belong to one of two genera in the Nemegtosauridae family known from the late Cretaceous of Mongolia, i.e. these are either Nemegtosaurus or Kazetosaurus. Whichever of these two Nemegtosaur species is present here, it's interesting that Attenborough describes them as long-necked Nemegtosaurs, particularly because we pretty much only have skull material for both of the Mongolian Nemegtosaur species, though I'll get back to that a bit later. As described in this excellent paper by Jeffrey Wilson, which thoroughly redescribed Nemegtosaurus, The Nemegtosaurids have a lot of similarities in their skull morphology with the Diplodocids, to the extent that the family was originally described as being a subfamily of Diplodocidae. However, he and several subsequent authors also found a number of characteristics which indicated that the group actually belongs within the Titanosaur lineage, having evolved a similar skull to the Diplodocids independently, probably due to convergent evolution. As far as we know, the Diplodocids now seem to be long extinct by the Maastrichtian, with the only lineage of sauropods that can definitively be stated to have reached the end of the Cretaceous, at least as of now with the fossil record as it is, being the Titanosauriforms. These unnamed Nemegtosaurids are presented as having particularly long necks, presumably because of inferences based on their convergently evolved skulls, that the Nemegtosaurids may have had similar body plans to the Diplodocids as well, though until we have more postcranial remains, this can't be certain. I say more postcranial remains because we do have some postcranial remains for Nemegtosaurus, and we probably actually have a lot more to go off. You see, in 2018, paleontologist Dr. Phil Curry and colleagues detailed the rediscovery of the original type locality for Nemegtosaurus, and found that it overlapped in time with another titanosaur from the region, Ophistoselicordia. In their rediscovery of the site, they uncovered a number of additional sauropod bones that may be from the same individual as the Nemegtosaurus holotype. While Curry and colleagues noted that they didn't at present have sufficient funds to properly extract, analyze, and describe the Nemegtosaurus body fossils, which doesn't help in reviewing this reconstruction, what they did discover, including the Nemegtosaurus's femur and parts of its hand, are extremely similar to Ophistoselicordia, to the extent that there's a very good chance that Nemegtosaurus and Ophistoselicordia are actually the same species. Ophistoselicordia was originally described from a skeleton that was near complete, inasmuch as it contained virtually everything behind the neck, but lacked the head and neck itself. The body of these Nemegtosaurs is likely to be based on Ophistoselicordia, but since we don't get the best look at it due to how much smaller it is than the more focused in on Mongolian titans. Presumably, the fluctuating status of the Nemegtosaur lineage within Titanosauria or within the Diplodocids are why the narration only refers to the Mongolian titan species as titanosaurs, since they might not want this to be an aged poorly moment if the taxonomy is revised to another lineage in the future. However, a number of other phylogenetic studies have placed the Nemegtosaurs in assorted positions within the Titanosauria, potentially suggesting that Nemegtosauridae might not actually be It's, as best as I can tell, completely flawless. A study of the oxygen and carbon isotopes of Tarbosaurus teeth by Dr. Krzysztof Owoki and colleagues in 2020 found that they have a carbon isotope signature typical of what would be expected of a predator feeding on prey that got the vast majority of its water intake from the plant material they were feeding on. In dinosaurs, this is a trait typical only of the very large herbivores such as sauropods and big hadrosaurs that take in large amounts of plant material, and within that plant material, the plant's water in each sitting. This indicates that sauropods like these were indeed a large part of Tarbosaurus's diet. The only issue that I have here is that in a holdover from Season 1, the narration refers to Tarbosaurus as Tarbosaurs, Now, this, for me, is a problem because usually when you say saw, it implies a larger grouping in paleontology. It seems to imply that, like, if I were to hear that, I would infer that Tarbosaurus was a genus of Tarbosaur, implying the existence of a wider Tarbosauria or Tarbosauridae family, but there is no such broader grouping. As I discussed in the first part of this video series, Tarbosaurus is a member of the Tyrannosaurinae subfamily within the Tyrannosauridae family. So it's super closely related to Tyrannosaurus, and potentially also super closely related to the Alioramins. So why he calls it a Tarbosaur, seemingly implying a wider Tarbosaur grouping, I have no idea. Okay, editing DJ here. I actually just had a discussion over Twitter with Dr. Darren Naish about this, which just happened. And apparently it was a conscious effort to vernacularize the scientific names so that they sounded less awkward when pluralized. For example, you would say Nemectosaurs instead of just using Nemegtosaurus as plural because it sounds less awkward. Or Nemegtosauruses, which also sounds a bit weird. I have mixed thoughts on it, again, because saw is usually used for a broader lineage. Um, but I do completely understand why this decision was made. Anyway, I'm just going to go back to pre-recorded segment. As the Tarbosaurus caused panic among the mixed species herd, the Prenocephaly are shown running up the hillside, where they're pursued by the Velociraptor family, one of whom ambushes the Prenocephaly, being chased in one direction from around another corner, and kind of hilariously, though unfortunately for the Prenocephaly, kicks it off a cliff.
Long live the king.
While I will stress that there is no evidence for pack hunting in dromaeosaurs, and even some evidence against it in Deinonychus, which I'll get to later, the behaviours seen here are interesting enough to be worth discussion. Using gravity to kill your prey on cliff sides is an excellent way of both conserving energy and minimizing injury risk, and it's seen in modern-day predators that hunt by cliff sides. Most notably golden eagles, which have been filmed grabbing goats and pulling them off the sides of cliffs before dropping them to their deaths. Now, this whole family are seen coming together after the hunt to feed on the dead Prenocephaly. This is where things might get a bit iffy. You see, in 2020, a study of the tooth isotopes of the related dromaeosaur Deinonychus found that the teeth of adults and juveniles of at least this dromaeosaur genus were feeding on different prey items, indicating that they weren't eating the same prey together as a family, as is shown in this sequence. I will note, however, that this might not be true for Velociraptor, as it's very probable that a large and diverse lineage such as the dromaeosaurs probably had variation in the presence or absence of social dynamics and behaviors between species. Still, based on these findings, I do find it unlikely that juveniles would have been primarily feeding on their parents' kills like this. Though again, not impossible and not implausible. We remain in Asia, probably Mongolia, and you'll get why I said probably in a bit, for our next segment, where we encounter a group of Corythoraptors guarding their nests. Attenborough notes when discussing Corythoraptor that you will seldom find more dedicated parents than these, and this claim is not without fossil precedent. You see, Corythoraptors were a type of Oviraptorosaur, a group of theropods related to birds, which have great evidence for their parenting dedication. This comes in the form of skeletons of mothers from the related genera Oviraptor and Cytipati, who died protecting their eggs from sandstorms that would tragically engulf and bury them. The main uncertainty I have with this segment is the species shown, Corythoraptor. First, I want to point out that there was no geographic barrier that we know of that could have prevented Corythoraptor from spreading across Asia, and therefore Corythoraptor being present at both China, where its fossils are known from, and Mongolia, where this segment is being set, it's completely fine. But, to date, there are no Corythoraptor remains known from the Nemegt, Baranguyo, or Jadocta formations, and a large number of other Oviraptorosaur species are present that we do know lived in the region at the time. There were at least 16 other genera of Oviraptorosaur that we know lived in Mongolian deserts in the Nemegt Basin. So the choice to go with Corythoraptor in this sequence is odd, to say the least. I think personally that it's unlikely Corythoraptor would have been present in this environment, given the large number of other Oviraptorosaur taxa and the distance between here and the type locality of Corythoraptor. But again, it's not impossible because there weren't any geographic barriers. My best guess as to why Corythoraptor was chosen is probably due to budgetary constraints, since they already had a model from Season 1, but I might be wrong there. I mean, why make a new dinosaur if you don't need to, eh? Regarding the eggs, we're presented with very long, narrow, pointy eggs for Corythoraptor. There's quite a bit of variation in just how narrow or pointy the different Oviraptorosaur eggs I've found in the literature are, but the shape of these eggs is pretty much exactly the same as what was illustrated in Jiming Dong and Phil Curry's 1995 paper that I'll talk about in just a bit. The nests displayed in this episode feature eggs that are arranged in a circular pattern atop a mound of sand. This is exactly the nest arrangement observed in a fossilized Oviraptorosaur nest, which was described in 1995 by Drs. Jiming Dong and Philip Curry from a remarkable nest and skeleton recovered from the Bayan Mundahu red beds of Inner Mongolia. Since this description, we also have a number of other Oviraptorosaur nests, likely from more distantly related species to the Corythoraptor shown here, like this one from South Korea, and all of them from species seemingly more or less closely related to Corythoraptor, have this exact same shape that is shown in this segment, with a circular arrangement of eggs. The fathers here are shown using their forelimbs to shade the eggs, and once again this is exactly what buried fossils of Oviraptorosaurs on nests seem to be doing. So once again, a flawless reconstruction of what's shown in the fossil record for this kind of behavior, even if I have a little bit of iffiness for what species is shown. As night falls, the Corythoraptors are able to begin searching for food, when an egg thief arrives in the form of the velociraptorine dromaeosaur Kurukula. This is the first time Kuru has appeared in any visual media, and this portrayal of it seems to use the exact same model as the series' Velociraptor reconstruction. Kuru was only described in 2021, and it's possible that their reuse of this model might indicate that the name of the dromaeosaur in this segment was changed late in production so that this animal could retroactively be assigned to Kuru instead of Velociraptor, so that we weren't all seen to be complaining about how many species kept showing up again and again. That said, I'm completely fine with these two species looking basically the same as each other in the show, as they are very closely related and would no doubt have looked very similar in life. I do think that this reconstruction might have benefited from some different pluming coloration to what we see in the Velociraptor, But it's entirely possible that the designers did change up the colours a little, and we can't tell because the scene's quite dark. That said, I've talked about this model in regards to its accuracy when used for Velociraptor, and how truly spectacular I think it is, being the most accurate dromaeosaur reconstruction ever put to screen to date. We're told that kudu has an advantage in being able to steal eggs because it has better night vision than the Corythoraptors. This, as far as I can tell, is based on a 2011 study of the scleral ring. That is, this ring of bones that you get inside the eyes of many vertebrates, including dinosaurs, from the closely related Velociraptor mongoliensis, in comparison with the scleral ring and orbit, that's the eye hole, morphology of other archosaurs. This study found that Velociraptor, and likely its relatives, had eyes that were particularly well adapted for hunting in low-light conditions. It's also really nice to see Oviraptorids being presented as caring and defensive parents, rather than as egg thieves for once. That said, I will note that Kudukula was found in different rocks to Corythoraptor, living in the Baranguyo Formation in Mongolia. That's not to say it couldn't have coexisted with Corythoraptor, but we do know of another animal that definitely did live alongside Corythoraptor, that certainly would have stolen its eggs based on the behavior and feeding habits of its modern relatives. That being Xiangxia, a giant lizard closely related to the modern-day beaded lizard and Gila monster. Given the sheer number of non-dinosaur animals highlighted in the previous episode, it did slightly feel like a missed opportunity to not continue that trend here, and it was a bit odd to me that they brought in an animal from a different formation to be Corythoraptor's egg thief, rather than using an animal that we know for sure lived alongside it. Possible missed opportunities are not mistakes, of course, and there's nothing to stop Kudukula or Velociraptor from living at the same place and time. But it's a shame to me that they did this when we have a probable egg thief living alongside Corythoraptor, and tons of Oviraptorosaurs living alongside Kudukula. But yeah, a great sequence otherwise, and clearly a lot of research was put into it. So, I continue to be impressed. We then move to the Barangoyo Formation, still remaining in Mongolia, for a sequence following a pair of young Tarchia. Before we see the Tarchia, we get a brief glimpse of an agamid lizard similar to the many modern-day desert-dwelling members of this family. Lots of extinct lizards are known from the Nemegt Basin, most from the Jadokta Formation, with a few also known from the Barangoyo Formation, which is shown here. The problem I have with this showing off of an agamid here is that none of the lizards from any of the formations in the Nemegt Basin that we have fossils of have been agamids. We have fossils of geckos, iguanians, Gila monster relatives, skink relatives, tegu relatives, and monitor lizards. Basically every single lineage except for the agama lizards, so I have no idea why one is shown as being here. Originally, I thought that these agamids were shown because they were a modern-day lizard that was common at the filming location and integrated into the scenes, and that the lizards we were seeing here were real lizards. But no, to my shock, that's not the case at all. Thanks to the artists involved in the series showing off their work, we now know that these lizards were entirely CGI, which kinda creates the new question of why they used a lizard that we don't know lived there at that time and place, instead of one of the many that we know which did. That said, this is an absolutely phenomenally realistic reconstruction, and I commend these guys for making a lizard so absurdly realistic that I and seemingly everyone else I've talked to thought it was a real agama lizard. We follow a pair of Tarchia who seek out water, finding a watering hole occupied by both Prenocephaly and an older member of the species, who's none too happy to see his watering hole being discovered. The reconstructions here throughout this sequence are excellent, and beyond that, I regrettably don't really have much to say about this segment. It's perfectly good and shows realistic behaviors. My only note is that we're told that the Tarchia have a mental map of the desert landscape, like most desert dwellers. Whether or not most desert animals' brains produce cognitive maps of their surroundings has been a matter of thorough debate. The jury still seems to be out on the vast majority of animal groups, though it seems likely for tortoises given their demonstrated very good memories, and the production of mental maps has been definitively confirmed apparently for bats. So yeah, whether or not it's true that most desert animals use mental maps to navigate in the desert is ambiguous, and I won't give a yes or no answer to its accuracy. It's certainly very plausible that Tarchia may have done so, given the memory abilities of desert tortoises, which are probably the closest analog to something like this I've been able to find literature from. Beyond that, I really don't have anything to say. It's decent, but there isn't much to talk about. So, on to the final sequence. The final sequence of this episode returns to the Isosaurus nests from the start of the episode, where we see the eggs finally hatching. First, the baby Isosaurus are heard calling to one another from within their eggs in order to synchronize their hatching. This ensures safety in numbers and is a behavior known from modern-day Nile crocodiles. Some freshwater turtles may also exhibit this behavior, and audio cues in the form of sound from other eggs hatching are also used to synchronize hatching in shield bugs. So, a lot of different animals have learned to use sound to synchronize their egg hatching independently, particularly when there isn't any immediate parental protection. Therefore, this behavior is very plausible to have evolved within sauropods like these Isosaurus. As the sauropod babies hatch, we see a feature that has not been shown on sauropod babies in media before, but evidence for which has been found in titanosaur embryos from the Upper Cretaceous of Argentina, that being the premaxillary horn present at the front of the mouth. This structure was initially interpreted to be a so-called egg tooth structure by Rodolfo Garcia in 2007, and then was observed again in more Argentine specimens described by Dr. Martin Kundreit et al. In 2020. Kundreit et al. Noted that the premaxillary horn of titanosaurs is structurally and compositionally different to the egg tooth found in other reptiles, and note that we don't actually know if it would still have been present at the time of hatching. However, being a structure made of bone rather than dentine and enamel, they note that if it was present at the time of hatching, and did serve as an egg tooth, which personally seems very likely, this feature would have persisted for quite some time as the animal matures, rather than quickly being lost like the egg tooth in other reptiles. They did note, however, that the horn may have been covered by a sheath of enamel and dentin, and this feature seems to be what's presented here. The young have been given a rather gross meal in the form of dung by their mothers, which in addition to providing them with nutrients for their trek to the forests from the volcano, are also claimed to give them smells in the form of pheromones that they can recognize and know to follow to locate their mother's herds. While I can't speak for the use of dung pheromones having a modern analog, the newborns of many modern megafauna, in particular elephants, which also live in arid environments, are known to ingest dung from their mothers, as it provides them with a lot of useful gut bacteria, as well as essential salts and plenty of nutrients that the mother's digestive systems failed to absorb. It's gross, but nature is like that sometimes. As the juvenile Isosaurus trek across the mountainside to the forest, we see one unfortunate individual fall down the side of a hot spring. Having no social bonds, its siblings just leave it, but according to executive producer Mike Gunton, we don't need to worry because, in the show's continuity, this little baby was rescued by the camera crew. Yay, camera crew! As the Isosaurus trek onwards, the winds blow away some of the toxic volcanic gases present, opening the way for predators to target them. Here we are greeted by an absolutely stunning reconstruction of Rajasaurus, the apex predator of India during the late Maastrichtian, and a member of the Abelisauridae family. This is the same family of ceratosaurs, which also includes the Carnotaurus and Majungasaurus, which we've also encountered in this show. And this might be my personal favourite Abelisaur reconstruction in the series, especially since its red to black colour scheme matches really well with the surrounding rocks of its igneous environment, helping it to blend in really well. But beyond that, the designers made some last-minute changes which dramatically increases my respect for everyone involved in making this episode. You see, on the original concept art for this episode, Rajasaurus, much like the show's reconstruction of the closely related Carnotaurus in Season 1, contains parallel rows of feature scales. But, as we can see here, this isn't what's shown in the final program. This is because, very shortly before Season 1 was released, a new study by Hendricks and Bell, which studied different portions of the skin from around Carnotaurus's body, found that these feature scales were actually randomly distributed around the body. This random arrangement of scales is also presented in Prehistoric Planet's Majungasaurus reconstruction from the previous episode, and shows that the designers working on the series were adapting their designs as closely as possible to the newest literature as it was coming out, and fixing a problem that was now known about from Season 1. So yeah, honestly, this was another great episode. The only real issues I had with it were the presence of an agama in the Nemegt Basin, some species which we don't know coexisted being lumped together, which isn't actually an accuracy. I just question why they didn't use animals that we actually know lived alongside each other. And some issues I had with the show's use of the word saw instead of saurus. Editing DJ, again, I had a chat with Darren Naish about this. So yeah, this was an intentional effort to vernacularize the scientific names. Ignore this criticism. I do still have issues with it, but I can tell what they were going for. So yeah, I'm gonna go back to non-editing me. But before that, I do want to say that I think that the narration calling Nemegtosaurus a Nemegtosaur when we have two genera of Nemegtosaur from the Nemeg Basin creates a level of ambiguity that didn't need to exist. Anyway, back to scripting me. But again, that's not really a massively important issue, it's more of a pet peeve. Otherwise, this episode did a phenomenal job once again at being as accurate as possible for the time it came out. Apologies if I seemed like a bit of a nitpicker at parts of this video. This was, again, an amazing episode. The fact that they even revised the Rajasaurus design late in production gives me a ton of respect for the people involved in the Deccan sequence. I think we can give this episode a solid 9.5 out of 10. Now, I was originally going to release this episode as a review of both Badlands and Swamps, but sadly I spent an entire week unable to work on this video due to Apple TV Plus constantly giving me error messages every time I tried to watch it, and Season 2 seemingly not being present on any dodgy streaming sites for me to try to watch it from whilst I waited for the official site to start actually working. During my downtime, however, I did write 2 more mini-episodes, which will be up soon, aimed towards geology and paleontology undergrad and A-level students, which will be on an introduction to echinoderms and an introduction to mollusks. The video on Balaur Bondok will also be up really soon, hopefully within the next 2 to 3 weeks. I actually recorded it around 2 months ago, but got held up waiting for some artworks, so we'll have to see on that front. But I'll be working on some more non-paleontology, geology, and climate-focused videos soon too. The next video in this series I'll be looking at will be looking at the science behind the episode Swamps, and I hope that that will be up within the next month, but because I have a lot going on, I can't say with 100% certainty. Again, I would really appreciate Patreon donations, and I will be updating you guys with the progress of all the videos on Patreon. Thank you very much for watching, and I hope you have a really nice rest of your day.